For this lesson, we'll continue going over string in math library. The sub function. Replace string.refers to string.sub. Add a second parameter with a value 5. Run the program and look at the output console. The resulting value is OME to IoT4E, a substring of welcome to IoT4E. Substring is pretty much a string in a string. It is a subset of a string. The function created a substring that starts from 5th position of the value of the variable text. This can be a little confusing, so let's try another. Inside the sub function, put 9 as the second parameter and 10 as the third parameter, then execute. The resulting substring will be 2. The second parameter of the function is the starting position and the third parameter is the ending position. The 9th character in the text is T and the 10th character is O, hence the resulting value 2. Next is the format function. Create a new file and declare 4 local variables as shown in the screenshot. Then write the format function. The first argument will be the temperature of the first room is %D inside the quotation marks. For the second argument, we'll call room 01 temp variable and assign this function as a value for the new variable response 01 and print it. The value of printed response 01 is the temperature of the first room is 65. As mentioned earlier with %S, %D is also a format string and it represents digits. Similarly, let's add a third parameter with argument room02 temp. Then change the first argument to the temperature for the first room is %D and the second room is %D and execute the code. The second parameter, room 1's temp, replace the first %D and the third parameter, room 2's temp, replace the second %D. And that was the final function we'll go over in the string library. Many other functions may be of use when programming, but the ones we went over today will be used repeatedly when programming IoT. Before we move on to math library, we'll go over concatenation as well. Let's make a new file. Declare a new variable called text01 and assign the value new and print it. Next, we'll use a concatenation operator represented by 2 dots to append extra characters to the existing value. Let's write text01 is equal to text01, 2 dots, then a space represented by a space between 2 quotation marks, another 2 dots, then world in double quotes. So initially, text01 was just a string with one word, new. Then we append the space and then appended world to text01. Add another print statement below and execute it. So when you print it for the first time, the value of text01 was new, but after concatenation it becomes new world. Let's try adding even more to text01. Using concatenation operator, append another space in the string IoT and assign it to text01, then print it. Execute the program and you will get new world IoT. Now let's move on to the math library. Make a new file. Declare a new variable pi and give it a value math.pi. The math we put in front of the pi serves the same purpose as string that was in front of all the string library functions we went over in the previous lesson, like string.format, string.lower, and string.reverse. We put math in front of the pi because pi is in the math library. So print the variable pi and execute. You can see that it gave the value of pi 3.14159265 and so on. Let's declare another variable. Local pi floor equals math.floor function with pi as its argument and then print pi floor. Once executed, we get a 3. What the floor function does is it returns the largest integer less than or equal to the given number. For example, if we use the floor function on -1.5, then we would have gotten -2. Next, put 2 negative signs on the line you declared pi floor to comment it out. This is called commenting. Every programming language has its own way of commenting out a line or multiple lines. When the code is executed, the commented part will be skipped so you can use commenting to describe what your code is or temporarily comment out the code to test it. In Lua, this is done by 2 negative signs. After commenting out the second line, declare a new variable called pie_seal and give it a value math.seal with pi as its argument. Let's print pie_seal and execute. We get a 4. The seal function is the opposite of the floor function, so it returns the smallest integer greater than or equal to the given number. In the next lesson, we'll go over for and while loop. If you have any questions, please let us know on the Q&A board. Thank you.